Hey everybody, today we are going to talk about acids and bases. The first thing I want to do when discussing this topic is discuss the pH scale. Now the pH scale, I've included two images here for you, whether you like your image vertical or horizontal. That's why I included both, whatever works better for you. They also have some different examples on them, which is beneficial. This pH scale ranges from 0 to 14. Now, you're going to want to draw one of these two pH scales in your notes. This is going to be essential throughout the rest of this unit. So we have the pH scale. It ranges from 0 to 14, as you can see on both of these scales. The purpose of it is to determine and rate solutions to determine whether they are acidic or basic. So they're given a number based on their contents, and it's going to determine whether they are acidic or basic. And you can do this through a simple experiment that we will do with litmus paper to determine what their pH is. Now, if you see on this scale, we have acids here and bases down here. You can see it again down here, acids over here and bases over here. 0 is extremely, extremely acidic. That is the strongest, most concentrated acid you could possibly find would be 0. As you progress, as the numbers increase, you get more and more basic. So by the time you get to 14, that is the most basic solution you could possibly have. Now you can see here in the middle, around 7, that is going to be neutral. So that is distilled water, like the perfect water is going to be 7. Most of the water you drink, though, like if you drink water out of the water fountain or anything like that, it's probably not going to be a 7. It's either going to be slightly acidic or slightly basic. But 7 is like perfect water. Battery acid would be like a 1 because that's pretty legit concentrated acid. Soap, baking soda, ammonia, all examples of bases. So draw that scale. From 0 to 7 are acids, and from 7 to 14 are bases. Right in the middle, at 7, that is going to be neutral, and that's going to be water. So make sure you have one of those, and pH, again, determines how acidic or basic a substance is. Now the first thing we're going to do is look at some physical or general properties of acids and bases, so you can differentiate between the two. As I stated just a moment ago, acids have a pH of less than 7. So if it is under 7, then it's going to be an acid. They can come in the form of solid, liquid, or gas. If you were to taste them, they generally taste sour. You wouldn't want to taste anything like battery acid, though. That would be a very, very poor choice. So they taste sour. Litmus paper, which we will use in the upcoming days. Litmus paper, it's just a small, little yellow, typically yellow paper you dip into a solution. If it comes out red, so if it comes out red, which I think this is going to be more orange, but nonetheless, if it comes out red, then it is going to be an acid. If it comes out red, that means it is an acid. Now the formulas for acids. All acids will begin with the letter H every single time. So hydrochloric acid is HCl. The H always comes first. Sulfuric acid is H2SO4. Nitric acid is HNO3. You can see with each of those what they have in common. They each begin with the letter H. They all begin with hydrogen. So that's how you're going to recognize the formula of an acid, is if it comes out and you see that it is starting off with the letter H. So starting off with hydrogen. So these are some basic properties of an acid. Let's look at basic properties of a base. They have a pH greater than 7. So 7 and above, from 7 to 14, those are going to be bases. Remember, 7 is neutral, so it has to be above 7 to be a base. They are typically solid in natural form, but they can be adjusted to come in liquid or gas. Like you'll explore and you'll see there are a lot of liquids like cleaning supplies and things that are bases, but in their natural form, most of them are solid. They taste bitter if you were to taste them. They are typically slippery in their natural form. and they are going to turn litmus paper blue. So when we put that paper in to a solution, if it comes out blue, then it is going to be basic. Now the stronger the blue color, if it's really, really blue, that means it's really, really basic. If it's really light blue, like it's barely turning blue, that means it's basic, but it's probably more around like an 8 or a 9. If it's really blue, that probably means it's a 14, because the higher the number, the more basic it is. Formulas. Formulas will always end in OH. So for bases, anytime you see a formula end in OH, that is going to be a base. So sodium hydroxide right there, potassium hydroxide right there, and magnesium hydroxide right there. All end in OH, therefore those are all bases. So that's how we are going to recognize it. Now, just as a recap, with acids, remember they're going to turn litmus paper red, and these are all the acids right here. The lower the number, the more acidic. So this is increasing. The arrow's facing this direction. If you have a 0, that is going to be really, really acidic. With bases, if you have a 14, that is going to be really, really basic. So bases, the intensity increases as the number increases. With acids, the intensity increases as the number decreases. So you'll want to make sure you include some arrows to show that acids get stronger as you move down, and bases get stronger as you move up. So those were the basic properties of acids and bases. Now, in terms of the ions that they produce, we're going back to ions. When placed in water, when mixed with water, acids are going to produce a hydrogen ion, an H plus ion. So anytime you see an H plus ion being produced, that means it is going to be a gas. Now how that happens is you place an acid in water, there's typically going to be a hydronium ion. So you want to know the hydronium ion, it's H3O. That acid is going to separate one of these hydrogens from the hydronium to create a free-flowing individual H plus hydrogen ion. So right here, the more hydrogen ions there are, the more acidic that solution is going to be. So this right here, this ion is what's going to produce our acids. The more, like I said, the more hydrogen ions found in a solution, the more acidic that solution is. So that is very, very important to note, that the more H plus we have, the more acidic it is. Bases, on the other hand, they are going to produce a hydroxide ion. That is OH minus. Anytime a base is placed in water, it's going to produce that hydroxide ion, OH minus. The more hydroxide ions found in a solution, the more basic that solution will be. So the more OH minus ions found, the more basic it will be, and the more H plus ions found, the more acidic it will be. So that's something that you will want to know. You're going to want to know that. So the summary down here, good summary right there. If the concentration of H plus is greater than OH minus, then the solution is acidic. That's what I said over here. The more H plus there is, the more acidic it is. If the concentration of OH minus is greater than the concentration of H plus, then the solution is going to be more basic. We're going to get more into acids and bases as we move forward, especially with pH and how we are going to calculate that to know if we have an acid or a base. But for now, farewell.